And we are live. Let me just double clarify everything is in order. Hopefully, my Twitch stream actually works this time, because it hasn't the last couple of streams. It might have been something to do with my OBS profile and like forgetting to switch it over to not the absurdly high bitrate version that I use for recording. But yeah, it should be more stable. I like logged out of Twitch and then relogged in, so hopefully that is all working. Okay, so what are we working on today? I have made the potentially good decision to start planning these out a little bit better, and like actually doing a planning session before each stream. So this is the current like planning document for Brane Engine. I downgraded Notion so it doesn't have like a reasonable site name anymore. However, it is publicly available. Not at a URL anymore, but it is publicly available. I wonder if the old URL I have linked in the Discord still works. Anyway, that's not too important. The important thing is, yeah, this is all public. You can look at it too. And this is how I sometimes plan things. And the plan for today is, did I actually write down the thing that I was planning on doing today? We were planning on doing... We were planning on like optimizing functions, which is what I put in the title of the stream. But did I put it on the planning document that I was messing with before the stream? I did not. Like, I went through and like added a ton of stuff to here, but not the thing I was actually planning on doing. So yeah, let's do that. So let's do switch function calls to use actual, to use native arguments instead of struct pointers. There we go. And that's how we're going to solve arguments. I'm not quite sure how I'm going to solve return values yet, but let's throw this into the in progress and get to work. And I'll kind of explain what I mean by optimized function calls. So one of the benefits of having a JIT compiled scripting language is stuff can be as fast as you make it. And in previous versions of BraneScript, we've just used raw function calls. Like all these arguments that you see here would have actually been those values. Like it would have worked like a regular function call using the C standard definition. Hey, how are you doing? I am doing quite well. We should have a good stream today. But right now, secretly behind the scenes, instead of passing in these arguments one by one, instead this is an anonymous struct definition. So the actual input to this structure is a, and it will be here inside of runtime. Will it be in runtime? Or actually, no, I need to search for JIT function handle. Yeah, which file is this in? Okay, it is in backend. It's just specifically defined in the LLVM backend, which it shouldn't be. This should be defined somewhere more global because we want the same function handle to be used everywhere. So I'm actually going to delete that from there because it shouldn't be hidden all the way in there. I guess I'll just throw it into runtime for now. And I guess is page size in common? Yeah, page size is in common. I guess this is something that is global. Do you ever try to go on vacation? For the moment, yes. I decided it's been a while since I've done a face, I guess this isn't technically a face stream, but it's been a while since I've done a stream like this, so we'll just do it. Do you suggest that I stop wearing suits and ties to casual environments, such as hanging out with the bots? Do what makes you happy. I don't really have any solid advice there. Yeah, so going back to... Not there. It's in the backend, runtime. In the runtime. JIT function handle. So this is the function definition that every single every single function uses, where we bind the memory. So I wish I had my drawing tablet easily accessible. Oh, hanging out with the boys. Okay. I mean, if they're chill with it, go for it. I can't doodle with a mouse well. But we pass in the binding to the memory. This isn't going to change. We're not going to change that. And then this is a BraneScript function pointer. I32 is what we store pointers in. It's like a packed 2 U16s. But yeah, so the way that we return values is replacing the values of the struct that was passed in with the values of whatever return value. So that means the caller has to allocate memory space on somewhere that they can pass a pointer to that is the maximum size of either the input values or the output values. Whichever one's bigger, they have to allocate that much memory, and then they have to copy the input values into that memory. And then after that, they have to replace all of that with the return values, which doesn't make any of the functionality inside of the function less efficient, but it does make the actual act of calling a function have a lot of memory copying overhead. So, what I want to do is come up with a method of reducing all of that. I don't want there to have to be a ton of copying into input values or copying out to output values. I would prefer that it's just Like, just works the way you would expect it to. Now, there are a couple of factors that complicate this. One is that I don't directly expose structs to LLVM. I do have structures in the intermediate representation, but I don't use any of LLVM's functionality for JIT compiling those structures. Instead, I just, in my LLVM, or my abstract representation, instead of having actual struct operations, I just treat things like pointers and struct offsets kind of like straight assembly code. Straight assembly code can't represent structs. And in the same way, my operations can't represent structs. I mean, I do store struct definitions for both debug and also reflection purposes, but not for actually JIT compiling stuff. So, and the reason why that's a big point is when we go to the LLVM backend, wherever it is in here, let me see where we function type. Oh, interesting. There we go. FN type. When we define this, you would have to, if we want to pass in structures, and use something like the C calling convention, so that we're actually able to pass function structures into things, we would have to have the function defined in LLVM itself for passing into functions to work consistently between things. So that gives me a couple different options that I could go with this. One is to do what I did with Brane script 1.0, and that is to completely say, like, you can't put functions in, you can't put structures into functions. You can't pass structures into functions. You can pass references to them into functions, but you can't straight up say, put this data into the function. That is one option, and then secretly behind the scenes, when we return functions, we allocate some space on the stack before we call the function, pass in a pointer to that memory for the return value, and then trust the function to set those values. Or I could do a combination of all of those, which I think is the direction that we do have to end up going to make this as optimal as possible. And that is when we pass structures into functions, what we're going to need to do is secretly behind the scenes turn them into a reference. So instead of actually copying the structure through the function arguments, unless the structure is small enough to be copied inside of registers themselves, and that's like an optimization we'll have to do later. But to keep it simple, if we're returning a structure from a function, secretly we will have an argument we pass into the function that is the pointer of where we want that function to put a structure. If we're passing a structure into a function, we secretly just pass a pointer to that structure into the function. And then if that function edits that memory, we don't care because we're going to do the Rust style thing of consuming variables, like borrow checker-esque management of that sort of stuff. Which I don't know if I have to come up with a lifetimes system for that to work properly, but it is like forcing the consumption of variables unless we explicitly clone them or copy them, implicitly copy them. I would like to do a little more research into how the Rust copy trait and size trait and all of that stuff kind of works. Though I'm going to wait until I actually implement a trait system, because on this list of things to do is the next thing we're going to do after this is make the type system a little bit more verbose. And then we're going to, after that, we're going to add trait. Well, actually, we need to add trait. We just need to implement traits in general. I might need to say, like, add built-in traits at the very least before we can actually add trait lookups, because lookups can only happen if there are traits to look up. So we'll probably create built-in traits, add those trait lookups to the compiler. Yeah. Sorry, my brain is going in like 100 different directions right now. And that's why I'm just like writing down ideas as I have them. That way I can get it out of my head and then focus on this thing that I think I should actually be doing, which is implementing this function thing. I guess the one other thing that I need to do is manage auto deref in compiler better. Because that is something that is bugging me, is how we're handling the value, like values versus addresses. And right now I'm using the terminology of reference versus dereference, temporary versus non-temporary values. And to do that better, we also should probably make add in mutable versus const behavior to compiler. Because that does make some of this make more sense. Because if we have a constant value or immutable value, then we don't ever need to dereference it. It makes it more efficient. We don't have to allocate memory on the stack forever. We can just keep it in registers. However, if it is mutable, that means we do need to store memory for it. Probably. We probably need to store memory for it. Unless I create something like a phi node, which I might need to. Then again, if I go the WASM route of basic blocks with arguments, I don't have to make phi nodes or make mutable values always on the stack. It really is like you only need a value on the stack in memory if you ever need to create a pointer to it. If you never need the memory address of a value, then you never need to store it in memory, actually. You can just keep it as pointers. And I don't know if that's an optimization that my knowledge of optimizing is fully capable of doing yet. But at least I have all of that kind of written down there. Because that is one thing that, like, my brain is very like overly concerned about, OCD about, and that's not using up too much of the stack, because we only have 64 kilobytes of, like 65 kilobytes of stack memory, unless we start paging the stack, or paging the stack pointer. So it needs to be somewhat optimized. Whereas right now, with all like the function allocations we're doing, it's not as optimized, and that's why I want to optimize function pointers. But one thing after another, how are we going to handle function types? So let me write out in here, since this is a convenient place to put this. Have you gotten a VR view working yet? Not quite yet. We're focusing right now on getting the scripting language working, and after the scripting language and its scheduler are ready to go, we're going to put those into the engine and start on a rewrite of the engine's compiler. Not compiler, graphic system. When we start on the refactor of the engine's graphic system, that's when I'm planning on adding in OpenXR. And that is when we'll have a VR view working in the engine. Is somewhere halfway through that rewrite. Alright, so we're changing the function signature from a pointer to memory plus pointer to input value slash output value union, because that's honestly what it is. When we pass it in, it's the input value. When we get it back, it is the output value. To instead I'm going to indent this so the formatting's a little bit clearer. We're changing this to instead a set of rules, and that rules are break the a pointer to memory followed by optionally a pointer to output struct location if output type is struct, and then break input structure members into types, into input struct into its members, pass each type or member as an argument to a function, to the function. As a native argument to the function. The native part is important because that means instead of passing in a pointer to memory, we're literally using registers, which are significantly faster. And then we also need to add in the caveat of if one of those arguments is a structure, pass a reference. We need to pass a reference to said struct instead. So this is now the calling convention of Brane script. Caller is expected to allocate memory large. Allocate memory on its stack or other memory and pass memory for poly and pass pointer at call time and pass in memory. Pass that pointer in here of the size of the output. Not of the size. I'm gonna say for said struct at call time and pass that pointer in here. Output values will instead be here instead of in function. Be here, and a function return type will become the void. If function returns a non-struct type or non-object type, return value through normal function through native function. Cool. So this is a fair amount of work, but it shouldn't be too hard. It does mean that when we call stuff, we will always need to know its call signature instead of possibly being able to construct that at runtime always, which was the benefit of doing it through the current struct system, is if I want to be able to call any function through reflection, I'm able to do that. However, in this new system, if I wanted to do something like that, I would have to add like some form of jitting to turn an input structure or input buffer values into throw those into registers and actually call the function. So I would have to like jit a little bit of a a small helper function to actually call the function with whatever arguments. But at the moment, I was like thinking about this because I'm like, do I ever need to call functions in a generic way. And I'm like, actually, no. In the vast majority of cases, I don't need to call functions in a generic way. Like, the singular time I think I don't need to is possibly maybe events. But even then, it's like events where things don't listen to arguments that the function is giving them, and even that's like on the coder's side of things to handle that. So at the end of the day, I think that I don't need functions to be generically callable. And I can just, if I do need to call a function from the host environment, I expect to know its signature. I'll just cast the function pointer to that type and then call it like a regular function. I will have to, on the host runtime side, account for the fact that you can't pass structs directly in, and they need to be either like small types or upgraded to references. But yeah, and in here, I may want to do something like allow the passing of very small structs through registers. So at some point I may need to upgrade this spec to, if it's a structure larger than 2 types, for instance. If this struct's smaller than 2 types, you pass in the members themselves. Like, you use the same system for breaking an input struct, and use that on that sub input struct as well to like fully break it down into passing each one of the members by value. But I think this spec will work perfectly well for what we need it to do for the foreseeable next couple months. So now I get to deal with the fallout consequences of that. No longer do we have a global function type. I can just delete that. This means for each one of our functions, we now have to create a signature. And this is where we implement this set of rules. Expand this out to the full page so we can reference it. And then I will have to like throw this. I will have to throw this into the BraneScript documentation at some point, because I do want a very well-defined API of how all this stuff works, so that if other people want to embed BraneScript into their systems, there are defined API. There is a defined API for things, at least for specific versions. It probably will be a pretty regularly breaking API, but at least it's documented that it is like breaking and whatnot. So now we need to define a system for building function types. But this is on the LLVM side of things. I also need to do stuff on the IR side of things, intermediate representation side of things. So instead of no op here, I'm going to change this to be instead arg value. And this is just because of the SSA form of how I'm doing all of this. I want argument values, like when we first access them, to be defined on the actual, in the intermediate representation with a IR opcode. Just to keep my, it is a little bit of a workaround, because the way to get around that is, sorry, I had to like buy viewer spot on Twitch. I had to nuke from orbit. What was I saying? Right. It is a little bit of a workaround that the index of this operand is the value of this operand. That is technically something I could work around somewhere else and not have it actually defined there. But I like this being the way that it is. And then additionally, if I am going to, if we do fully optimize function calls by the end of this stream, we need to add in function calls. Add in function calls, which I knew I was missing some important things here, but I hadn't put like add in function calls into the like actual thing yet. Ooh. So add in function calls, that goes literally right here. That's like the next thing we do. And right above adding in explicit function calls, let's call this explicit function calls. Before that, I want to implement defining non-pipeline stage functions. Because currently the only way we're defining functions are as parts of pipelines. I can't define a standalone function quite yet. It literally would be one function's worth of code to implement non-pipeline stage functions, because I use the same logic for pipeline stages that I would for actual functions. Because they're literally the same thing, just disguised with a little bit of scheduling magic thrown on top of that. But other than that, they are both defined as functions with the same, most of the same grammar and whatnot. So if we get this argument refactor done, we implement the ability to define functions, and then we implement the ability to call functions. Now I do need to fix this, so argument value, this will be, whoo. And do I need to implement it anywhere else? Not quite yet. So that takes care, well, did I add a return? I did not. This is the arguments type. I think I'll do that as well for return, because next stage is a different form of return. So this is the type that we're expecting to return. Well, actually, so with next stage, the next stage can have a different return or different argument values. So return, let's call this return value. And then here, this is just return and return value. Maybe I should make it return, but with an option type instead of having it as two different things. I think I am going to do that, where it's return. We will have a type because there is a unit type, or a, what's the term for it? A memberless, anonymous tuple. In Rust, that's what it is. In mine, it's a memberless struct. So if ID_ref is referencing a memberless structure, then output should be a none value. IR value does not implement standard format display. I guess I do have to do this as like a match. Or we can just do if let out some out val. All right. That takes care of all the formatting for the things that we need to add to get this all working. And next... Oh. I guess for next stage, we do still need that. That does still need to be a structure. So I don't change any of the code there. Well, actually, I do change the code there later because I want it to be an API binding sort of deal instead of calling the return value of the function. So now this is where I will implement this whole deal. Potentially. Or not. Not yet. We're jumping the gun a little bit. Because this is the back end. We need to make these changes in the compiler first. Potentially even parser. Do I actually... Wait. Do I actually do any function calls at all? Aside from next stage, which is pretending to be a function call and still does need a structure as input, like a structure reference as input, I don't think I actually do any function calls, so I might not have anything to... Yeah, I don't have anything to refactor. Real quickly, I am going to check compile function. Just to say if I need to do anything to the call sig. But at the moment, all we do is create a anonymous struct type. That will get recorded in the module. So potentially we have a anonymous struct that doesn't end up getting used in our actual code, as well as, in the case of debug build, any extra debug information. But we don't need to worry about optimizing debug build, since the entire point of those is to be as verbose as possible at the cost of some optimization. And I don't really care about optimizing data size of debug builds really at all. Speed, maybe. I want debug builds to still be usable. But like, binary size? Nah, that doesn't matter at all. We have plenty of RAM. Is this really all runtime side at the moment, since I actually haven't implemented function calls? It is. So let's just go. Let's just go right back to the runtime. Right here, where we were before. Where I keep procrastinating creating the function type. Yeah, just function type is equal to and this is the only place. Is this the only place where I define function types? Since the compiler has already gone and put every single function that will ever exist into the BraneScript module, and we're currently iterating through that list of every function that will ever exist, it follows that I would never define another function type after this point. So I can create another function if I want to, but I don't need to. That means first we need the return type, which is, we could match. We can do ret type because we do have the first thing we need to worry about is the return type. If the function returns a non-struct type, we need to return the actual value regularly. If, however, we break input to, if we have a structure that we're returning, instead the second argument to the function will be a pointer to a pre-allocated bit of memory that we need to return to. So we need to do that optional switch here. And regardless of type, regardless of if they're structures or not, or I should say, instead of non-struct type, this should be a, if the function returns a single member, struct type return said members value through the native function return. Let's see, if the output type is a say struct with more than one member, caller is expected to allocate memory for said struct at call time and then pass a pointer. In output values will be recorded to that pointer, and the function return type will be void. That is an easier way to think about this. So we basically need to get that structure type, which I'm currently forgetting how I handle structures. Let me find where we deal with members, structure members. Oh, we don't. We don't deal with structure members because by this point, the compiler has compiled structures into non-existence. But they do still exist in the intermediate representation. So do I have a self build function? I don't. It's literally just build module and then build ops. Build op the op values. So we'll go let ret type equal, and we could even do the entire function type in a really, really long single line statement, which would be multiple lines, but you know what I mean, like single, no curly braces there, and except in curly braces, large, huge block of code. But I'll just do return type for now. If dang, I do have to do a... Wait a second, no I don't. I can do BS module, get struct, and then pass in this function's output. And then this is an option. So I'll go let output t is equal to BS module get structured output. If not output, oh. I'll just do my usual match guard on this. If this is sum, I'll just say value. If this is none, then we'll bail. Throw an error. And this error will be function output type. About the recent Next.js exploit. Something about bypassing authorization checking. I have not heard about this. Luckily, I don't really do anything with the Next.js that is currently deployed. So hopefully by the time I do deploy anything, that will be patched. That doesn't sound fun though. Output type f output. Let's also do input t get struct input, and I do pass this by reference, right? I hope I pass this by reference. Yeah, it's option reference IR struct. Let's just do the entire function type. I will say if output t dot members length is let's say less than 2 because I want to do the simpler case first. Then we want this to be self context. I believe this is the LVM context, right? Yeah. Then I have the get LVM type. For I need some way to handle void types here. So if this is a 0-member structure, we need to return void or int type. Or handle that ourselves. Because I don't trust this generic function to handle all cases unless I start passing other arguments to this, like allow void, true, false. Use of JavaScript turning into a war game scenario feels like often seeing an exploit or vulnerability found in some JS framework. Yeah. All, the huge tree of dependency is becoming an issue. With, super large systems like that, it is often really hard to individually validate every single dependency. Then again, with bypassing authorization checking, in Next.js specifically, they are the ones that maintain the auth framework. Because you're talking about next auth, as in the Next.js package for authorization, right? That extends your Next.js website to have either JWTs or database-based logins. I wonder if it's their JWTs got cracked. I wonder if I could do this as a match statement. I think I can do this as a match statement. So if it is 0, then we want to do context cvoid or self context. This is a void type. If this is 1, then we want to do self context. And we actually do need to do a check of, is this a structure? Wait a second, no. We break out every single member option, so it's just value. So I'm overcomplicating this in my brain. Our ship video showed it as a 9.1 score on severity. Oh joy. Well, I mean, it is an authorization thing. So that is quite quite large concern. And this is the output type. Wait a second, output type. That's why I wanted it to be the way that it was. Brane, you're not doing input types. You're doing output types. We do want to match statement this. For 0, we want to return, not arguments, return a self context void type if we return one value and that value is not a structure. Not a structure type. I do have some duplicate behavior here. Where I need to do if return type output t members 0. Let's do reference here just to be safe. If let some ret if this is a native return type, or rather if this is an IR native type. Wait, would I only be able to check for... Wait. Yeah. This would need to be a ID type, IR type, native. There we go. That's the right syntax. And I think that's valid. Expected. Okay, yeah. Those are the errors we want to have. And on this branch of it, if we have a native value, we can just safely do self get LLVM type native return. Wait a second. Since get LLVM type automatically treats structures as always pointers, and what I was going to do over here was wait, no, this is return type, so we do need to have a optional return value, or not return value. So I'll have I'm gonna turn this into a union here, not a union. We're turning this into a tuple, where on the left is what the function returns, and then this is going to be an optional that is this optional structure return value. And then for this value, just say return argt. In this case, we want to return expected IR type. I guess I can just pass return type in. IR struct member. Ah, true. So I just throw in R type. And I guess here I just say we don't care about the actual value. Then we also throw a none into that branch. But in the case of there actually being a value, we want to swap these. So instead we do a self context void type. And in the second value, we return a sum of, and it is always going to be a 32 pointer type. However, I'll let this be, since I am going to refactor that later, I'll let that sit there. Basic type enum. Can I into? In school, they never really give you an impression of just how much you use structs. They're kind of taught like they are a stepping stone towards the development of classes. I guess in my brain, I have classes and structures filed underneath the same category. In some cases, they're the difference between value type versus reference type. In some languages, like in C#, all structures are value type, and then all classes are a reference type, so that's like important for passing stuff and references. But then in C++, there literally is no difference, except for structures by default, all the values are public, and in classes by default, all values are private. So literally only an encapsulation difference. Maybe something to do with inheritance. There's a difference there, but I've never run into anything. And like structures can inherit from classes and classes can inherit from structures, and it like, yay, different keywords that do essentially the same thing. With structures just kind of being like a convenience thing. But then if you're in anything like low-level systems programming, then you only have structs, and it's fun. Ways to group variables. I wonder if I can just throw an into on this and if it will be able to actually okay, it's not implemented, so I do need to manually turn this into a basic type enum, which I believe the LLVM type does. Yeah, basic type enum. Basic type enum void. Oh wait, basic type doesn't have a void type. I guess I would have to do an any type enum. But this isn't getting imported. There we go. Void type. Throw that in there. And let's also throw this in here. And now the error will be here, right? If and else have incompatible. Ah, it's still complaining here. So I need to throw this into an into. Or not. Any type enum from basic type enum isn't satisfied. Oh, come on. Oh, there's a try from for basic type enum. But is there, let's see, implement context from basic type enum to basic metadata type enum. Then enum type set, does this have a from? It does. But that's a from each one of its arguments. Oh. Yeah, I'm just like, come on, just implement the thing, make it easy on me. And what I'm doing right now is basically the same thing of like, oh come on, it has to be implemented somewhere. Oh, I want this as for any type. Really? Really? And then I just pop the headset off my head and like, woo! I match the requirements. Fulfill the Boolean. And we stand on a box as I T-pose. See, this is a wrapper for basic type, void type, or function type. Perfect. New. There's as basic type enum. See, it has downcasting, but not upcasting, if I'm using those terms correctly, which I'm very possibly not. Like, those are all individual types. There's totally a way to cast this super easy. Basic metadata type. Does basic metadata type have a void type? Array, float, int, pointer, struct, vector. And metadata type as a... Ooh. Okay, that's literally metadata. Basic type enum plus metadata. Oh, vectors are for SIMD operations. That explains it. Because I was like, why do you have arrays and vectors? Vectors are like usually resizable arrays, and I wouldn't think that a backend is implementing resizing arrays for any language. But if vectors are SIMD vectors, that makes a lot of sense. It's a vector register. That makes so much sense. Okay, but how do I turn this into an any type? Can I try into it? Ah! Don't want to have to match statement this. That would be ridiculous. Let's see, we're just gonna inkwell docs. I could have manually defined a cast by now, but I don't want to. There's as any type enum. Implement any type for any type enum. There's an any type trait that defines as any type enum. Let's see what implements the any type trait. Ooh, look, the basic type enum implements the any type trait. So that means that I don't have to define a cast, because I can go as any type enum. There we go. Instead of implementing into, they did custom traits. Which is fine, I guess. So then we can say, let a function type equal oh, I will have to make changes to the compiler. Because now function arguments, because the way we handle arguments is different. So I have to make changes to the beginning of a function call so that we yoink all of the argument values. And then from that point forward, we can treat it as normal. But that's the only change I'm going to have to make to the compiler. So now our function type is going to be equal to the return type then we need to do function type on it. And I do as any type enum, and then, well, it already is an any type, right? Yeah. Does it need to be an any type? No, void type is a, yeah. Okay, I need to call function type on this type. Basic type. Right, basic type provides function type, and void should also return a function type. So I should do a match statement here. Or wait a second. Type safe bindings are sometimes annoying. Or rather, builder pattern bindings. Function type, I do need parameters. Are there. This would be fine if enum had if any type enum had function type bindings. So we will match on return type, and if return type void type it is a void type, that means we can do void t function type like so, but then we do need the same arguments. What if this is part of a trait definition? It's not. Is there anything like try function type? I would love if there was a try function type for any type. There's metadata type function type. Basic type, of course, but void is left out as a function type. So to make my life easy, well, no, it still has to be two different function definitions. I can't really get around that. We'll do a if let sum or rather not sum, need to do that, then else be okay, and this okay will be basic type, and this will be return type, not as any type enum, as basic type enum. No, try into is what we want. Nope. Today I decided to do a face stream just for the fun of it. It had been a hot minute, and I'm like feeling guilty for not using my my camera. Remove the unnecessary generics. There you go. No more unnecessary generics. Watch as it goes. I have no clue where you're calling that function from, because I don't know what you're trying in doing that. So now function type requires a slice, so, and then is it variable argument? Well, I already know I am not planning on supporting variable argument functions. I have literally never needed to use variable argument functions, ever. Aside from like print statements, and even then I would prefer to do like a print macro type situation to handle that. So next we need to do let function arguments is equal to I'm going to do this. Is there a way to insert inside of an iterator statement? Like if I did return argt threw that into a slice or array, iterator, and then zip that with, actually no, zip isn't what I want. Can I do append? No. It's like I need a conditional starting value here. I guess I can just do an insert. Vex splice. And that takes in 2 slices. So let's do that. Oh, it takes in 2 iterators. That's actually perfect. Let's do vec splice. And what we need to splice is return argt now becomes sum a, and this will be a slice with a, none becomes a slice with nothing, and that argt is a basic type. So then we just do input type it members iterator map archetype, and then we can just do self get LLVM type for arg_t. Okay, I was going to be very surprised if that worked the first try. Do we need more parentheses? Expected 3 arguments. What was expecting 3 arguments? Splice? Vex splice seems... Oh, maybe it's... Ah. Chain. Iterator chain. Let's go. Oh, wait a second. If I chain with that... How did the video is more likely... Now... I'm honestly not worried about avatar versus no avatar video retention. Honestly, I think the avatar would retain more viewers, if I'm being completely honest. Like, who wants to look at a human face? So, like, 2015. In here, instead of doing get LLVM type, we'll just get a reference to the type as the arg. That way, when we chain the iterators, because I am over optimizing to not do multiple allocations. Nope, that's not what I wanted to do. Come on, let this work. There we go. I need to map before chaining it. Which I guess means that I need to switch this back to get LVM type. Expected reference IR type, found IR struct member. Right, because this is a member, so we'll just throw that as MM type. So your local bratwurst vendor is not my target audience, unless they're an avid VR chat fan, which would be something. And entirely possible. Yeah, perhaps not. Basic type enum reference? Would this be a reference? Maybe it's a reference because I did iterator? Or maybe into iterator is more fitting here. Oh, and we get back to the same same problem of this not wanting to play nicely. I guess we'll just turbo fish it. Basic type enum. Right. Needs to be. Oh, you can just cast it. Oh, wait. The iterators are a specific type? Oh. Let's... So these aren't slices. They're statically sized arrays. I was thinking of them as slices. That's why I was messing. That's why I was having issues there. Then this wants references. I'll collect here. It defeats the purpose of doing this entire like huge thing. I don't want that to be a basic type. Guess I really can't just into a generic iterator over a certain type and then chain. This to another iterator of a type. At what point do I give up and just put in 2 memory allocations? Oh wait, the into iterator actually, well, that's because I did ask slice. Here it doesn't matter, but like I can't do references inside of here because they'd be escaping references. So I guess what I do is I have to do two allocations. Let input args equal that. And then let's collect this as a vec. And then instead of doing all of that madness, we're going to do input input args splice or insert. That's immutable. Splice takes in a moot self as well. Okay. See, that's why I wanted to see if I could do like inserting an iterator, because imagine I could just do like insert and then throw like 1 extra argument in there and then we just continue mapping. It would have been so clean. And then we want to say if let some return arg. All right, and finally we can say input args as slice. Because I think this takes a slice. Yeah, it takes a slice. And it takes metadata types. Interesting. This should... I think just into works here. And then here I need to do into as well. And then it works. Type must be known at this point. Ah, yep. See, I said, like, it was complaining. Remove unnecessary generics. However, look at that, the generics were necessary. Screw you, Rust Linter. Or actually, would this need to be on the other side of the turbofish syntax? How would I do a fully specified path or fully qualified? Okay, so you have to like define the whole trait. Try into, and then or actually is there a try from trait? No, there's just from probably. So we'll do try into. Wait, could just be basic type. Expect any type, return type. Return type is any, it isn't any type enum. Expected basic type enum found any type. I'm trying into basic type enum. Why can't it, like, work? If I go here, and no, that one needs to be any type. Return argt. This is the only place it is, so I could do the cast here. Basic metadata type enum. I don't want to be spending my time trying to cast enums. This is the less nice part about Rust. Tracking down large giant match statement casts. Oh, there is a try from. Maybe I can just do from. It appears to not be complaining. Oh yeah, no cast needed. As it should. I guess in this case I'm just... that's like ignoring output values, which I don't want to do. Oh, wait. Trait and scope. Okay, thank goodness. Oh. That was significantly more complicated than it should be. Then again, I did make it hard on myself. How am I doing on time? I'm doing alright. Here we go. Well, we now define function signatures not correctly yet. Return type if there's only one return type. Otherwise, wait. Type structure. If this is one structure, we return that singular structure. Yeah, I think. Okay, so if there are multiple return values, we want to return it as an implicitly created structure. Which means the return type in that case is literally just the output type. And then we run the same code. Well, in this case, it would never be native, so we don't actually have to do that match statement. We would just do output T. We'll just manually put this in here as a pointer. And then if I do my planned refactor, of making the type system more verbose, I'll just go back in here and yeah, just go back through and fully implement stuff. The correct types. So this will be like, actually no, this still would be in an I32 type after that refactor, so it's fine. But now that is a proper function definition, I think. Yeah, the other errors here. We just have to make everything else fit. So one thing is arg value is now a thing. And we're going to have to return in this case, it's similar to load, but we're grabbing one of the function arguments. See here, I push one value to the stack, which was the previous stack pointer value. Which, thinking about it now, I do still need to pass a stack pointer. So this can mostly stay the same. Maybe, maybe not. See, the reason I had no ops before was if you referred to the value of the no op, it referred to the values of the arguments. However, I'm not sure I want to directly expose the stack pointer as an argument that intermediate representation can interact with, because I'm worried that potentially that could be used in some malicious way. However, I'm pretty sure there's going to be workarounds to get to it. So we could just define it as an actual value. Let me look at how I'm doing load, because it's similar. We don't need this int pointer. I guess I just do build load. No, that's an LLVM thing. Oh, wait. I'm like thinking like, oh, how do I make sure this gets pushed onto the stack of values? But that's the reason why no op just directly returned, was because each one of these pushes onto the value stack. Right. So all we need to do here is push a sum value. Basic value enum from func. Then we need to get arguments. Args. Input args, return args. Get nth param. LVM function. Oh wait, here I have function as the IR function. And is this already a basic value enum? It is, so I can just do get nth param. Like so. Perfect. So here's return. And I'll leave this as a to-do for now, because I'm not implementing full functions today. We're just implementing better function signatures that make sense. And yeah, having that complain is fine for now. JIT function handle. These are going to have to be generic for now. What's the type for Rust generic pointer? Rust void pointer equivalent. Okay. Wait. I think I'll just use the backend specific type here because yeah, I'm just gonna set this to unit and see what it breaks. There it is. So address is LVM orc address. Yep, that's a pointer. So I guess this is the type. I'll just keep it as an address until we request it. Now I bet there is build up, right. Context defined. Okay, good. Does this implement copy? It does. So this doesn't need to be a borrow. Oh, and we still aren't using IR function. Okay. Oh, wait, there is one other place that we might need to generate function calls, and it's here in call. Actually, we might do that when we import, like have a list of imports, figure out the function signatures when we go over that list of exports, and then here we would just search that predefined list of imports for that function. Or search the LLVM module. Yeah. We don't need to define function definitions there. We do, however, need to define them somewhere else. So I will need to do the function definition or function type code in two places. Not today, though. Now we get to move on to the compiler, or move back to the compiler. And here we have the fun task of recreating that logic, but from this side of things. Oop, I just smacked my headphone cord. Where is input pointer used? Okay. This is where I'm dereferencing every single one of the struct members as an input pointer, but we don't actually need to do that since we're passing all the input struct members as actual arguments, which also means I want to avoid compiling this anonymous struct type if I can. At least for input. Let's do set args is equal to call sig self, or no, call sig input members map. And then member types are value context. So I want the type and the label. That's the type of the argument. Do this as a filter map. That way errors will kind of bubble down. I think for now I'll do this as an anonymous tuple. So we'll have the same thing I do here with the label. We'll have the actual label be first, and then the type be second. And now we have a list of all the types we need. This can be member type, but it's a option type context. Yeah, let's do a M type okay or on this. Okay, and then... Now this needs to take in an error, which means... Oh, wait. Anyhow, not bail. That's why it was unreachable. Let's as ref that. Expected toolchain message. Found error. Through. The errors are different. I will... Let's do less nesting of huge rustisms. Then some P equals T. And none we do fail. Archetype not resolved. Then we can just match on type again. Wait, I can't bail. This returns an option. So I'd have to do this instead. Do I ever record error? I do. We will record error arg type not resolved for type m context. There we go. That gets all of our types for the arguments. However, for the case of any input structures, I do need to do one final thing. R type is the result of resolve type ID, which returns an IR type. It's going to be native or struct. And we're going to say let if let R type let type equal if let if this is a struct. Honestly, a match could work here just fine. Giant chain of matches. Then on the struct type, of a struct type, I want this to be a reference. But here's the hard thing. Oh wait, I do still have it as a label. We're good. Maybe. I'll fix that when it breaks, and it will. If this is a struct type, we instead change it to native type. Let me just pass through the iron native type real fast. And this probably will get changed into a pointer type, but for now it's IR native type I32, which is a int pointer. And now we get to do something similar for the output. Or for the output, we just have to determine how many members there are. Actually, do I need to define this here? Oh, I do, because I am defining it. And when I write it, I do need the... Oh, right. I do need to define the input structure as part of the IR. So we'll still fully grab both of these structures. Oh, and that gives me an ID ref. Right. Module. It's structure, input. And this is pretty safe to unwrap. And then the types of each one of these is already going to be resolved, isn't it? So all I need to do is this final stage of... Yeah. So it's ID. So that gets our arguments, except for in the case of needing to return a structure. And in the case of needing to return a structure, which is if output say output def is equal to module get struct output unwrap And if output members length is larger than 1, actually we'll say do I actually need to define an output type here? I don't think I do. All I need to do is purely check if I need to add a structure to it. Don't need to pass that to anywhere else. Say if that is larger than 1, then into args we want to insert at index 0 a new type, which is a 32-bit int representing a pointer to the return value. And this argument won't have a name because it's just a pointer. And we also need to do this actually twice. This is a stack pointer. And this is the returned struct pointer. And yeah, I'm just going to keep it as insert twice. As long as you don't have a function with hundreds of arguments, we should be fine. Performance-wise. So now in here, instead of doing input members, what we need to do is iterate over arguments, reference args, I, and then the label is just arg0. Ah, I'm going to say for arg in, actually, index. I'm going to do this the correct iteration way, which is args in iterator enumerate. I believe that's not very useful. I think the index is first, though. If arg 0 is none, then continue. We don't need to set up a labeled value for it. Say arg. Oh, that's why I was matching. Let sum ID is equal to arg. ID, or 0. And I think I can into iter this. And now we can actually consume stuff. And we'll just say writer set labeled value write ir op arg value. The index of this is going to be, well, index. Rather convenient. And then we will have a value context. Alright, there is a missing parenthesis somewhere. See if I can spot it. Ah, that looks correct. Mismatched closing delimiter. Maybe it's... Oh, wait. Because structures take curly braces and I'm dumb. There we go. Not document context. We want IR value context. And the type of this argument will be... Ooh. This is guaranteed to be... that's my headset running out of power. Or rather, the backup battery running out of power. Headset's fine. It has like this smoke alarm, like beep, beep, beep sound it does. That invokes panic. So we want to put in here the type of that's in the input, but the problem is that that index isn't going to be accurate. Our type is equal to input. Since I need to reference this again, we'll move this get struck down into its own variable. And here we'll say input def ID no. Members. And then index minus skip indices. And there we go. That correctly gives us the type. And then we need a match on this type. And if this is a structure, it will always be a mutable reference. If this is a native type we're trying to pass in, it's not a pointer type, or not a register, or whatever you want to call it. These are memory addresses, so we say is deref false. Which I need to refactor that system as well. And I have that on the list of things I need to refactor. So it will be done. And then when we set labeled value, we need a writer IR value, which means we can say writer set labeled value ID, and then unwrap the result of writer write, because it will always return a value if we pass in a sum value there. No, that can be. Try adding a local. Cannot borrow writer as mutable more than one at a time. Ah, okay. Even though I think the whole write will be done by the time that's done. I don't think that's a problem. And there we go. We now have all of our stuff working. Also, hello, Shadow. I finally fixed the Twitch stream, so it's actually working. It hasn't been working the past couple streams, but yes, back to Rust. Probably for longer now. So I may or may not have rewritten the second version of Brane script entirely in Rust over the course of a week. I am further along in it than I have been before, so the Rust rewrite actually was pretty helpful, and I think I may have just finished the current refactor. Right now I'm rewriting function signatures to, instead of accepting struct pointers for every single one, instead we use actual native function arguments. Compiler metaverse, that is the file we are currently in. Ah. I think this can just be vec new, and then if I go back to where I was before, and we set value is that. Oh, wait a second. This was one of the skipped indices. Yeah, rewriting is not usually too bad. I've once switched to OpenGL libraries in Java, around 300 files in around a week as well. Yeah. Did the fact that Java is like a slightly different language hurt that at all? Because I know with like C++, it's pretty similar to Rust, and then I was using like standard variants and whatnot a ton. So the rewrite wasn't hard because I was already writing in Rust style C++. But like with Java, would that have made it any harder, or was it mostly like utility / bindings-esque things? Mostly the same. All right. Okay, and with that, the new arguments are pretty much correctly bound. The biggest thing is each file has separate imports, and they have to be explicit, so that's a pain. For the Java side or the Rust side? It's like Rust still has like a ton of implicit uses, or explicit uses. Java? Ah. Could not compile Brane script CLI. Rust, you can bundle imports to make it way easier. Oh, you mean like the little curly brace syntax? Like this whole deal? Instead of having to do multi-level nested. Yeah, because each one of these being on its own line, that would be annoying. So our problem is now in the BraneScript CLI, probably when we grab the functions themselves. Yeah. See, I need to convert these into function pointers. Java, every class is a separate file. Wait, like it has to be? Like Unity mono behaviors, but even worse? That's like... So like if I made like a, let's say a vector3 class, can you store structures in the same file? Or does Java have structures? But yeah, if I want to do like vector3, like little tiny utility class or structure, would that end up, that would just always end up in its own file? I feel like structures would... I feel like Java would have an implementation for structures because C# has an implementation of structures and they both use the JVM. Let me get the current implementation of the JIT function handle. Which is this. And I need to essentially write a custom pointer type here. Well, once you have a private class, that's only accessible within that file. Nope, all classes. So you can define private classes that are accessible within the file, but it only exports a single class, if I'm understanding that correctly. Doesn't seem... I mean, I can see it being like a very opinionated thing. Like, oh, it forces you to organize your project well. But then there's like... I mean, having everything be forced to be object-oriented is also a choice that you can make, that Java very strongly makes for you. So then, let's see. So I have my memory page binding. I have my stack pointer. And then this takes in 3 I32s and doesn't return anything. Because currently that is a pipeline stage, and the next stage doesn't directly return anything. If I did do like a return command, it would. And then this one will only take 2 arguments. Zero args is equal to... why did I switch to C? A is equal to 5, B is equal to 3, and C is equal to 6. So now I'm going to keep that same syntax. I'm not going to write it anymore. I'm going to call that return, because it actually is the return value now. Then we say we're running this with S0 args. That is such an unergonomic thing to type. Why did I do that? And then this returned those args. Or actually, I'll just do stack after call, since that isn't necessarily how I want to handle returns anymore. And the stack after call will... Oh, wait, I can't chain them if I don't read the stack afterwards. Dang, I have to bring... Oh, wait, return. There we go. And now we can say running with there is no C arg in this case. Well, I'm with args. A is equal to that, B is equal to that. Throw all of this into an unsafe. There we go. That should still chain the call the same way, and it should work the same way, but this time we're actually using real function arguments instead of structures. So the LLVMIR should be significantly smaller, or at least the that is an error on the back end. Well, let's look at the arg is not a value. Arg is not a value. So this is a problem with function arguments not working. Oh, that wasn't what I wanted to do. And now this is going to try to run forever. If I just terminate it and rerun it, it will be faster. Because the debugger takes forever. There we go. Same panic. Let's go up the stack. Oh. Get nth param. This is for... Where is this? I do want to do get nth param. Zero is a pointer value. Then this is the stack pointer. Function add multiple. Two. Both of them using struct with no arguments as their arguments and return. It's weird. Go back up here where we create the function type. Let's just do this the non-fancy way, since my fancy way was very much messing it up. So we need a vector of input arguments. For archetype in input. I don't even really need to do the map. We can just have the map be the body of this. And then say input args. Push these values. Then for this vector, I want one initial type of self context int32. I32 type. And that is our, actually no. We want one pointer type. And that is, that pointer type. We also need the stack pointer here, which is not explicitly defined, I think. Or at least it isn't defined by the compiler. It's not part of the type. Then I need to just throw an into on both of these and make the type of this a basic type enum. But it needs to be a basic metadata type. And then function type needs to be created after these two are input. So first we do the two predefined types. They go into the function always, the memory bindings and the stack pointer, and then conditionally we insert a return pointer, and then finally we push the types of all the arguments. Now we shouldn't get the complaint that our function doesn't have a memory bindings pointer. We still are getting an arg is not value, error in members initialization. Is this the backend? It is. I need to be in compiler. Actually, we can just find string. What was I looking for? Right, arg is not value. Well, that is descriptive. It's one of any of these. Error in members initialization. So this probably has to do with something in here. Wait, I don't need to write this because I access it implicitly. In fact, I don't want these to be accessible. And wait. Arg index. I don't want the other two to be directly accessible. I also need to do skip indices here. But I do want... Okay. I do want to write args here, but I don't want the stack pointer to be one of them. Okay, now it will write one pointer to a return struct, potentially, optionally, and then the rest of these will be actual arguments. And that potentially fixes it. Still have the arg is not value. Let's go to any one of these. Binary operator is probably the one. And then wait a second. It's not value. I'm getting my different things mixed up. I did have the stack pointer as an accessible argument. Read only? Where's this read only? Okay, I need to compare what I'm doing on the back end to what I'm doing on the front end. This is so close to potentially working. Okay, so we have these two arguments. I'm pretty sure I'm creating the function signature correctly. So what is actually important for me to look at is how I access them or provide access to them. Am I thinking of the input pointer? I'm thinking of the input pointer. I didn't give people access to the stack pointer. I gave people access to the input pointer, which in this case would be the output pointer. And then here, wait, this is the compiler. Or no. This is what I was thinking of when we're getting arg values. ID, right labeled value. We're finding arg is not value. So some new thing is throwing off the indices of this. Because we're not even getting to the point where we're trying to chit it yet. Arg is not value. It's probably to the binary operator because that is the first time that we attempt to access a labeled value. Let me find the references to this. This is what's supposed to be finding our stuff. There's a chance that we aren't labeling values correctly. Yeah, that's just running. If I put a breakpoint there, do we hit it? Oh, we don't hit that either. That's not a good sign. This should be hit. If this isn't getting hit, it's a problem with my debugger. No, that got hit. And then args turned out to be 0. Ah, okay. We are compiling with the output struct, which is nothing, as the input struct. There we go. Now we actually are defining arguments to the function. That looks significantly more complete than before. So now we have arguments. I add args for not both int values. Pointer and sub I32. I add args for not both int values. I add args for not both int. Well, now JIT isn't working, but compilation looks correct. Because we integer multiply 0 by 1. Yeah, look at how much smaller this is than it was before. Like, sure, we have all of this stuff to do with creating output structures twice, but on this one we only make an output, well, we still make an output structure twice. But the actual function right here, all of this is return value, stuff that we're going to optimize later. This is fine. If I had this defined as a regular function, not a pipeline function, there'd be one more thing here, which would be return. And that would be all it is. Alright, I add args for not both pointers, or int values. I add which function was this in? So we bail. Can I anyhow build up? I'm gonna say with context. Where f is function once, the returns display. Okay. Do I have the function name anywhere here? I could yoink. You know, I would prefer if this just context Oh, wait. If I do context... then I can just throw a string in. I think. In function. And now that error will tell me which function that was in. Okay. In multiple 0, I add. There are 2 I adds here. Print compile function add multiple operation 4, which tells me it was this one. We are adding argument 0 to argument 3, which is 1 negated. Oh, I know what's going on. It's because... this. We need this to be plus... placeholder params. So let me change this structure so we have ooh. I mean, I can just recompute it on the fly. Potentially. Can I? So we know that parameter index is always going to be 2 plus index. Because we have the memory bindings pointer, the stack pointer, and then conditionally, if irfunc output I have to get type. I could also just check the LLVM function. Or wait. I can do something super easily here. Super easy. I just do arg offset is equal to the LVM function count parameters minus IR function ah dang. Well, I still have to input parameters. But output type, I do just have to check the output type. Or no, I can grab the input type. We grab the input type and then module get struct IR func input if we've gotten this far, it will have already checked that this value exists, so then we can just say input type members length. Oh, wait. There we go, and let me guess, this is Cool. Now every time we access an index, we just go, how many arguments does the user know about? Ah, they know about 3. There are 5 arguments. That means the first 2 arguments of this function are special arguments. So we're going to ignore those and continue on with our day. And now we won't add a pointer to an integer. We have an error. While actually calling the function. Let's look at what the intermediate representation looks like then. Alright, so we define add multiple S0. Wait, did it literally crash on the first instruction of the function? This, I think, I think it crashed on the literal first instruction of the function. Maybe. Add B. Wait a second. Is it saying that this isn't valid? Like the function pointer? Wait, no. No, this should be fine. Transmute wouldn't work if this, yeah, because if I did function mute, transmute would fail. This is a true function pointer. But this is saying add B add byte. Then it's calling a function. My code doesn't call functions. So it's trying to call this function, but failing. But we found the symbols. Like, stage 0 exists. It undoubtedly exists. What about S0? Those are some suspicious looking zeros. Almost like that was sign extended. But that's the... That looks like a correct amount of zeros. If I don't standard mem transmute this... Found reference to U64. Wait. Reference to U64. So what if I just dereference that reference instead of straight up transmuting it? Well, the first one ran. Oh. That's to be expected. This is working. It's my collar code that's broken. Here, let me, like, force the memory to be aligned. What if I... Where's the stack page? Where is it? There it is. I just need this stack page itself to be aligned. As U size divided by 4. And then I'm going to make this a U32. And now it will align it. Expected raw pointer const moot UA. Oh, UA. And cool. Hopefully that aligns the memory addresses. Because I don't want to have to do like standard mem dereference unaligned. Well, that's a good workaround for forcing aligned memory allocations. Ooh, wait. Now my now my dereferencing of things is incorrect. Because add adds the size of the type. There we go. Oh. 5 minus 3 is in fact 2, and then 6 is carried over, so that is working correctly. And then we get 12. Let me check what my current example script is. The two values times each other. 2 times 6 is in fact 12. So we can say that the refactor is in fact working. I don't have any code that uses return values yet, so might as well be working. We'll figure out if that isn't working when we add in more functionality that actually requires that. But yeah, function calls will actually be fast now. Like, when I was thinking about turning all of this into a stack machine, I was like, oh, I'll just pass values into functions on the stack, and it will be fine, because everything else will be on the stack, and it will all be optimized by LLVM. And I'm like, I really don't like the idea of function calls themselves being a bottleneck. I don't like the idea of functions themselves being a bottleneck for my scripting language, because then data throughput itself becomes an issue, and I want everything to just be fast by default. So we're putting in the extra effort. We're actually doing functions with arguments, and then if I ever need to do reflection-based calling of functions, then that's my problem. We'll JIT call those. But yeah, that will be it for this stream. We got the thing working. Let's go and commit this. All right, there we go. For those of you who stuck around, thank you, and I will see you next time.